بسم الله الرحمن الرحیم. عرض سلام و صبح بخیر خدمت دانشجویان عزیز و محترم. فصل 4 رو به اتفاق شروع میکنیم. مسیریابی و انتشار داده. Good morning. Hi my dear student. For this session we start with chapter 4, routing and data dissemination. For the first time we should have a look to the introduction of this chapter. Routing and data dissemination are an important issue in wireless sensor networks. The essential function of WSN is to monitor a phenomenon in a physical environment and report sense data to central node called a sink or base station, where additional operation can be applied to the gathered data. This chapter focuses on routing and data dissemination in WSNs and introduces the fundamental concepts related to routing and data dissemination, discusses the major issues and challenges in accomplishing this vital function, and surveys a variety of protocols for routing and data dissemination in WSNs. We present a taxonomy of routing and data dissemination protocols for WSNs based on different classification criteria. For example, location information, network layering and in-network processing, data centricity, multipass, network dynamics, quality of service requirements, and heterogeneity. Taxonomy is developed through an extensive analysis of a variety of routing and data dissemination protocols for WSN. The objective of the taxonomy is threefold: to provide a framework in which routing and data dissemination protocols for WSNs can be examined and compared. 2, to show how the routing and data dissemination protocols can be categorized according to this taxonomy. And 3, to gain new insights into the routing and data dissemination protocols and thereby suggest avenues for future research. Okay, more specifically, the taxonomy comprises 2 types of classification. One that classifies routing and data dissemination protocols with respect to sensor deployment, for example, sensor mobility, where sensors could be mobile or static, and one that classifies them with respect to trade-offs between different metrics specific to sensing applications. For example, energy efficiency, low delay, high data accuracy, and fault tolerance. Also shown are the benefits of sensor heterogeneity in routing and data dissemination for WSNs. Fundamentals and challenges. First, we define the terminologies that will be used in the subsequent sessions. Then we introduce a commonly used energy model in most of the protocols for WSNs. Finally, we describe the Venn diagram, which has been widely used as a model of WSNs. Terminology. Sensing range. The sensing range is like a disk, okay, is like a disk with radius Ri, including its boundary, centered at zeta I, the location of the sensor Si, and defined by an area disk with location and center zeta I and radius Ri, is a set of points that these points are located inside absolute value zeta I minus zeta less than R, where absolute value zeta I minus zeta is the Euclidean distance between the locations zeta I and zeta. This is sensing range. So the sensing range is the area that sensor can detect any changes of a physical parameter. Transmission range. Again, transmission range is like a disk that a sensor can send its data to the another sensor, the maximum range. And again, this is a disk like area, and but the radius for transmission is capital Ri. For sensing is small Ri. For transmitting is capital Ri. Okay. Neighbor set. Neighbor set are some sensor nodes that are located inside transmission range. Neighbors of node Si are Sj nodes that are located inside the transmission range. This is the definition of neighbor set. Coverage. We say that capital A is an area. A point P belonging to this area A is said to be covered or sensed if and only if it belongs to the sensing range of at least one sensor. So, coverage includes all points that these points at least are under sensing range of at least one sensor. The area A is said to be covered if and only if for every point P belonging to A is covered. This is the definition of coverage. Heterogeneous versus homogeneous. We I told for you the meaning of homogeneous and heterogeneous in wireless sensor networks. If storage, computation, communication, sensing, and energy capabilities are the same for all sensors, that this network, including these types of sensor, is homogeneous. Otherwise, it's heterogeneous. Communication range. Communication graph. Communication graph of a homogeneous WSN is undirected graph, a graph that there is no direction. Communication graph G include set of sensors S, capital S, and include capital E, set of edges, set of links between sensors. So a graph includes sensors, includes links among sensors, and if we have a homogeneous network, our graph is undirected. Otherwise, the graph is directed. Okay? Okay. We consider edges or links between each two sensors if Euclidean distance between these two sensors less than transmission range. Otherwise, that sensor between SI sensor and SJ sensor, there is no link or there is no edge. This is the definition of communication graph. Definition of connectivity and fault tolerance. Consider the graph G that includes S and E, represent a network. S is set of sensors, E is set of edges or communication link between sensors. We say that G is connectivity for G is equal to K if and only if G can be disconnected by the removal at least K nodes. You have a graph if you remove K nodes from the graph and your graph becomes disconnected. So in this case, K is connectivity. K is connectivity. Removing K nodes of one graph leads or result in disconnectivity. In this case, K is connectivity. And K minus 1 means the graph is yet connected. With removing K nodes, our graph becomes disconnected. With removing K minus 1 nodes, our graph is connected. So K minus 1 is fault tolerance of our graph. This is definition of connectivity and fault tolerance. Venn diagram. Consider set S includes members S0 up to Sm minus 1, a finite set of M sites in the plane. The Venn diagram of S, we denote it by var S, is a subdivision of the plane containing S into M Venn region. So we have Venn region for each sensor Si. For each sensor Si, we have a Venn region. And the union of all Venn region for all sensors is called Verney diagram. So Verney region is a subset of Verney diagram, and union of all Verney diagram region is called Verney diagram. For example, here, this is a node. All points inside this Voronoi region, all points inside this Voronoi region are closer to this node than to this node, than to this node, than to this node, than to this node, than to this node. So all points inside this region are closer to this node than to this node, than to this, than to this, to this, and to this. So we call this area Voronoi region. Each node has its own Voronoi region. Voronoi region. Okay. So an union of all Voronoi region is called Voronoi diagram. Okay, Voronoi region, Voronoi diagram. Voronoi region, Voronoi diagram. Another definition: multi-hop communication and single-hop communication. This is SK node, and this region, this is the transmission for SK. This is transmission for SJ. This is the circle, and this disk is transmission range for SI. This disk transmission range for SJ, and this disk transmission range for SK. Okay. SJ can send its data to SM directly. So we have a single hop communication. But SK cannot send its data to SM directly, and should send its data by using two hops. The first hop SK to SJ, and the second hop SJ to SM. So if the next node is not inside the transmission range, we should send the data by using more hops than one hops. Okay, this is single hop communication and multi-hop communication. Energy model. In energy model that we use in the paper to calculate energy consumption of each node, we should consider two terms: energy consumption for transmission, energy consumption for reception. Energy consumption for transmission has two terms. One term to drive electronic circuit, one term to send data to the distance d. If we have k bits to transmit, k electronic is the term for driving the circuit, and epsilon k d power alpha is the term for sending k bits to distance d meter. Alpha is between 2 and 4, and epsilon can be epsilon free space or epsilon multipass. It depends on the environment. And the energy that we consume for receiving is just K E electronic. For transmission, epsilon K D power alpha plus epsilon plus K E electronic. For reception, just K E electronic. And total energy that each node can consume is addition or summation of transmission energy and reception energy. So this is energy model. In routing and data dissemination, again we have some challenges. We have some challenges. Again, sensor characteristics. Again, sensor characteristics. Sensor CPU, sensor bandwidth, processing, battery, these are sensor characteristics. Sometimes a sensor equipped with GPS. Okay, these are sensor characteristics that we should consider in designing routing and data dissemination protocol. Field nature. We have two important points in the field nature. Sometimes when we scatter or deploy sensor nodes in the field, especially randomly, maybe some parts of our area or the field cannot be covered by sensors. So that part is, or these parts that cannot be covered by any sensor are whole. And we say that we have a coverage hole. Coverage hole. Some areas that are not covered well, or even not covered at all, which would lead to a problem known as coverage hole. Another point is connectivity hole. Connectivity hole means our sensor can detect physical parameter, but our sensor doesn't have any neighbor to report its data to that neighbor node, and finally to the sink. So like a person who trapped in an island. I don't know, you have read the book of Robinson Crusoe. A person who reached when his ship crashed, the sea wave brought him to an island and live in that island lonely. A sensor can detect a physical parameter but cannot report its data because there is no neighbor around it. We have a hole, we have a connectivity hole. Okay, and these are because of field nature, because of field nature. And another challenge is network characteristics. Network characteristics. When we deploy sensor in the field of interest, sensor try to make links among themselves, and so they make a topology. But because of failure, because of energy depletion, this link can be crashed. Because of addition new sensor to the network, we have new link. So it means the topology of the network is dynamic or can be changed frequently, and this is because of network characteristics. Another challenge is network scalability. Sometimes we increase the size of our network, and we should consider these items. Sensing application requirements. This is another challenge to design a routing protocol. Sensing application requirements. Sometimes based on the nature of each application, maybe for a special application we need high accuracy. For another application, accuracy is not important, but reliability is very important. For another application, delay is very crucial. So, depends on the nature of the application. Some parameters are so important for us, and we should consider them. Okay? Okay. Taxonomy of routing and data dissemination protocol. Here we are going to classify routing and data dissemination protocols, but we categorize them based on some criteria, and these criteria are location information. In some routing protocols, we need to have the accurate location or position of the nodes. So some routing protocols are located in this category. Location information is so important. We use GPS or we use localization technique to obtain the exact coordinate of each sensor node to design an accurate routing protocol. Network layering and in-network processing. Sometimes in our routing protocol we use a flat network. Sometimes we use a hierarchy network. In a flat network, the role of all sensor nodes are the same. But in a hierarchy network, the role of nodes can be classified in normal one and some cluster head. Normal nodes that are belong to a cluster head send their data to the cluster head. Cluster head aggregate data and then relay to another node. Okay, so being flat or being hierarchy is resulting our designing. Sometimes inside our network we have some special node that make in-network processing, and this in-network processing help us not to send redundant data and correlated data. So this is another category for routing and data dissemination protocols. Data centricity category. Data centricity category means all communication between sensor concern name data. Okay, concern name data, and this is data centricity. Another category is path redundancy. Sometimes we just make one route from the source to destination and we maintain just one route, but in some application we have a main route and maybe have one or more than one alternative routes. And of course maintaining these alternative routes consume more energy, but it bring us high reliability. Okay, path redundancy. Network dynamic. Again, network dynamic goes to mobility, goes to connectivity, to whole connectivity whole, coverage whole, and so on. Some nodes, base station, or ordinary nodes are mobile. We have one sink or more than one sink, static or mobile. So because of these network dynamics, some routing protocols are located in this category. The next category is quality of service requirements. What are quality of service requirements or parameters? It depends on application. As I told you, delay, reliability, fault tolerance are more important quality of service parameters. But and depends on the nature of the application, we can design our routing protocol based on these parameters. Network heterogeneity. Network heterogeneity again goes to the same specification of the sensors. If we have same hardware and software specification, in this case we have a homogeneous network and we design our routing protocol for this type of networks. Otherwise we have a heterogeneous. It means our network is equipped with advanced nodes that have bigger storage, more or bigger storage and advanced CPU and the capability to transmit and receive is more than the other nodes. This type of network are heterogeneous network, and we consider our routing and data dissemination protocol in this type. Okay, from this part we can see some old routing protocols that I skip this part because they are old ones, and you can refer to valid journals, download the recent papers from them, so no need to study this part up to the end of this chapter. At this time we have a break, and at 10 I start the next part of our session. Okay. چطور آقای دکتر؟ حال شما خوبه؟